Okay, so now in section 8.3, we're going to talk about graphing reciprocal functions. So remember when we had a function like this, or we had like this, right? We said that there was special values that we couldn't have in the bottom. So we would say like x cannot equal -3, or in this case, x could not equal, well, these would be different ones. But anyway, we would say that x cannot equal those values. And we said that that had to do with graphing. So here it is. We're going to talk about it. Now, these are called reciprocal functions. Why do we call them reciprocal functions? Because remember back when we had like a number like 6, its reciprocal was 1 over 6, right? And so if we have a function x, its reciprocal would be 1 over x. And so that's actually our parent function is 1 over x. And the graph looks like this. Now, what I want you to notice is a couple important things, okay? Well, first off, we know that x cannot equal 0, right? Because we have 1 over 0. So we draw a dotted line straight up and down saying x cannot be 0. And that has a special name. We call it an asymptote, okay? Now you'll also notice that that our graph actually goes kind of like super close to that dotted line, but never touches it and actually switches directions, okay? That is because of the type of function that we have. And it also says that we can never get f of x to be 0, right? And that's because of how it approaches this way, right? And that asymptote is called our f of x asymptote, and that's going to be 0. It's like it's kind of sitting on that line, right? Now, we also know that there are no intercepts in this case. It doesn't cross any of the axes, right? But it could be x or y axes that it crosses. And finally, we know that it's not defined at 0, and that comes from this function 1 over x, and x cannot equal 0. So where is it not defined? It's not defined at 0, okay? So let's look at a couple examples, and we can get really good at figuring out where things aren't defined at. So if I look at this one, x plus 2 in the bottom. So it's not defined at -2 because -2 plus 2 equals 0. Not good, okay? Next one, x minus 5. Well, it's undefined at 5 because 5 minus 5 equals 0. Not good in the bottom. Finally, the last one, x equals 0, which is not good at the bottom, right? And so we can figure out how things are undefined by setting the bottom equal to 0 and solving for our variable. And so that's what we're going to do in example 1. It says, determine the value of x for which this is not defined. So we start by saying 2x plus 5 cannot equal 0, right? And so we solve it like an algebra problem. Subtracting 5, we get 2x cannot be -5. Okay, divide by 2, and x cannot be -5/2. This would make the bottom 0 and thus undefined. Okay, so here's a couple guided practice problems for you to try on your own. Now, example 2, we're asked to find asymptotes, domain, and range. So I'm going to start with my asymptotes, and I'm going to abbreviate them ASY. Now, the x asymptote is the up and down one. So I find that I have a straight up and down, okay, a straight up and down asymptote right there. And so I count over, that's 1, 2, 3. So that's at x equals 3, which if you look at the function, x minus 3 on the bottom, x shouldn't be 3. That makes sense. Now, the next one, f of x, what's its asymptote? Well, that's the one it's laying down on. And so this one's laying down on 0. And so our f of x is 0. So now we look at our domain and range. Remember, domain is our x values. And I can pick anything except for 3. So I just write it as this for simplicity's sake. X cannot equal 3. It can be any other number in the real number set. It just can't be 3. Let's look at the range. That would be the y values, right? Okay, so our y values. Now this comes from our other asymptote, and it would be 0. So that would mean y cannot equal 0, meaning I can get any value of y except for 0. Again, for simplicity's sake, we'll just write it like that. All right. Now, letter B, same thing. Asymptotes, okay? And it looks like I have a straight up and down line through -2. So my asymptote for x is -2, and f of x is, and this way it's going to be -1, right? And so then I say my domain is x cannot equal -2, and my range is y cannot equal -1. All right, hopefully that was a little bit easier, and hopefully it's super easy for these guided practice problems that you have now. Okay, so example 3. It says graph each function and state the domain and range. Now, we already have these graphed on here, and you could do the same in Desmos. In fact, why don't we do that? Okay. All right, so we'll go to Desmos, and we're going to type in our function, which is 2 over x minus 4 plus 2. So it would be 2 over x minus 4, and then plus 2. All right, so here we go. So we have it right here. You'll notice over here our x asymptote, okay? Our x asymptote is going to be, I'm not quite sure what happened to our graph here, but it's going to go through right there, right? And then our f of x asymptote is going to go through the 2 right here, right? So we'll go back here and we'll say, our domain, right, was x values, and for this one, x could not be 4. In our range, it was y could not be 2, right? And that came from our graph. We can do the same again, all right? And if you wanted to, you could graph on Desmos. Otherwise, they have it here for us, right? Okay. So our domain is x cannot equal -1, and our range is y cannot equal, in this case, it would be -4, right? Because there's 0, 1, 2, 3. There's -4, okay? So here's a couple guided practice problems that you can try. Start by graphing, okay? Graph, and then 2, state domain and range. All right. All right, so here's a real world problem that we have. It says, an airline has a daily nonstop flight between Los Angeles, California and Sydney, Australia. The one-way trip is about 7,500 miles. Write an equation to represent the travel time from Los Angeles to Sydney as a function of flight speed. Then graph the equation and explain any limitations to the range or domain of this situation. So this is what we're going to do. All right, so we're asked to write an equation to represent travel time as a function of flight speed, then to graph the equation. So we want to go 7,500 miles over x for some speed. So if it was, if, let's say, for example, we can go 7,500 miles per hour, right? So then this would be 1 hour, right? Or if it was less than that, like 3,700, right? And so then that would take, that would take 2 hours, right? And so on and so forth, right? And so what we can do is we could graph it. I'm not going to graph it on Desmos because I think you could figure out what this is, right? But it says explain any limitations on the domain or the range. Well, obviously, our domain, right, is x cannot equal 0, right? And so what that basically means is you can't be going 0 miles an hour, right? Because then you're not moving, right? And so that is impossible. Also, our range is y cannot equal 0, meaning you can't instantaneously go from Los Angeles to Sydney. It just doesn't make sense to do that. So the only limitations that we have for these are that you can't be going 0 miles an hour, and you can't instantaneously show up between the two continents. Okay? All right, I'd like you to try number 4. It says the junior and senior class officers are sponsoring a homecoming dance. The total cost of the facilities and catering is $45 per person plus a $2,500 deposit. Write and graph an equation to represent the average cost per person. Then explain any limitations on the domain and range. I want you to try this one now.